still. Okay, good morning class again. And I'm sorry I was not here on Wednesday and I sent you an email, I think at 2 a.m. It was late at night or early morning, whatever. So please go through lesson 9 if you haven't already and check the quiz 3. It will be available till Friday. Okay? And lesson 9 is not included for test 1. So today the plan is we will go through the topics which will be on test 1. And just few reminders, your homework 3 and quiz 4 both will be due on Monday before class. I haven't uploaded any of those yet. I will do that. And I uploaded the practice problems for test 1. If you want to submit the solution for that, even if it's not correct, even if it's not complete, maybe you completed 1 out of 5, that's okay. If you want to submit those, do that tomorrow by 5 p.m. You can get some extra points. It's not mandatory, but it will be a good practice for you. Even if you don't submit, just go try to solve the questions, okay? It's not mandatory, but it's highly recommended that you do that, okay? And one last thing, reminder. So in last semester, what I did, I held a Zoom session, which is from 10 p.m. to 11 p.m. I know it's late, but that's when baby goes to sleep. So I will be available on Zoom on Thursday from 10 to 11 p.m. It's obviously not mandatory, nothing, but if you have any last minute question you want to ask, and I know by that time, obviously you'll go through all the lessons and everything. So if you have any last minute question, you can just log in and ask me a question. Okay, so that is the reason for Zoom session. You don't have to come if you don't have any question, but if you have any question, you're welcome to stop by. Okay. Okay, and the test 1 that will be in person. At least that is the plan till right now. If something changes, I will announce what you need to do. Okay, so for test 1 review, everyone should have 1 copy of this one. All of you have that? Okay, good. So for test 1, the syllabus is from lesson 1 to 7, homework 1, 2, and the quiz 1 and 2. Okay, so that will be the syllabus for test 1. Lesson 7 is the one where we completed all the surface tension, capillary rise, and capillary rise equations and everything. So that will be the syllabus. You are allowed to bring, obviously, your prepared self. Otherwise, it will be a bad day for you test-wise. Please bring your calculator. The calculator, if you want, you can bring 2 calculators because sometimes 1 calculator doesn't work. Make sure you bring pen or pencil, eraser, straight edge. Straight edge is good. It will be good to find some value from table or from graph. This one. And the last thing, the equation sheet. You are allowed to bring 1 equation sheet of this size of page, but just 1 side. Okay. You can write down all the equations, all the abbreviation like rho equals to density, m equals to mass, v equals to volume, something like that with proper units. You can write down that. And you can draw some picture also, which will help you to understand the equation, like which one is volume, which one is something like that. But no concept, no theory. Like there shouldn't be any concept, any theory on your equation sheet. That should be in your brain. Okay? Yes. No, you don't need to bring appendix A. You don't need to bring temperature conversion, anything. Anything which is constant, like appendix A, I will give you that. But I will not give you the conversion between centimeter to meter or from millimeter to meter. I will not give you that conversion, but I will give you the conversion from feet to meter or meter kg to slug, something like that. Okay? If you want, you can write like the millimeter to meter, that one. Yes, yeah, you can write on that. No, you can write down the equation, but no concept, no solution, nothing. Okay. Now, one thing what I did, if you go to the Canvas page here under the module, here I uploaded one equation sheet CE309. Basically what I did, I took some snapshot from your FE manual, which you will take next year, the FE exam. So it's good to be familiar with the FE manual also. So what I did, I just took some pictures from the FE manual and I added here, okay? FE manual didn't have any equation for the bulk modulus and ideal gas law. So I added those here. So what you can do, if you want, you can download that and write down your anything extra you want to add, or you can make your own equation sheet. I don't care whatever you are using. The only thing is it should be within one page. So if you download that, make sure you squeeze down everything into one page. You don't need that much details, limit and everything. You can cut out that part and everything. Okay. You just need to make sure that it should be one page, one side. Okay. And it is on the module. And one thing for homework solution, if you go to the assignment part and go to the homework here, you will see homework 1 solution, homework 2 solution. There, if you want to have a look on that. Let's get back to the class here. Okay, the question format will be, there will be a few multiple choice questions, just like the FE exam, with no partial point. For each question, there will be 1 point. So if you can answer the question, you'll get 1. If the answer is wrong, you will lose 1 point, but there is no negative mark for that. There will be mathematical problems, maybe 2 or 3. It will be similar to your homework problem. Maybe like I will break down each problem into multiple parts and you have to answer each part. And you will get partial points if the steps are correct, but maybe the numbers are wrong. You will get some points for the steps. So I ask you, please write something. Don't give me the blank copy. In that case, I don't have any way to do any. Okay. And the extra credit question, every time I ask 1 or 2 extra credit questions, if you can answer those, you'll get some extra point. If you can't answer that, that's okay, because those are extra credit questions. Now, the learning objectives on test 1, what I did, it is from every lesson I covered, I just copied all the learning objectives from the slides there. Now, if I miss anything here, still that will be on the test, as long as it's within lesson 1 to 7. And you can remind me if I missed anything. So the first thing we discussed, different type of unit system and different type of characteristics for the matter. Now, can you remind me what was the main difference between fluid and solid? How can you tell this is a fluid or it is a solid? What was the parameter to decide? Just by seeing that, like how can you say the water is fluid and in book is solid? How they react against the shear stress? Yes. So the solid, they will not deform continuously. After some point, it will stop. And for fluid, if you keep applying the shear stress, it will be deforming continuously, right? Okay. Then we discussed density, specific weight, specific gravity, bulk modulus, ideal gas law. Excuse me. After that, we define viscosity and Newton's law of viscosity. After that, we discuss Newtonian and non-Newtonian fluid. So the fluid we saw in the lab, that was Newtonian or non-Newtonian, the mixture of water and cornstarch. Like with different type of force, it was acting differently or it was same? It was non-linear because under different magnitude of force, it was acting differently, right? But for water, it will act same all the time, no matter what amount of force you're applying. And at the very end, we discussed surface tension, capillary, and capillary rise. And we also discussed why with higher force, we are getting small amount of bubble, and with small magnitude of force, we are getting higher radius of the bubble, right? Did I miss anything? Okay, even if I miss something, still it is not. You can go through your lesson 1 to 7, everything from that. Most probably I didn't miss anything, but go through every lesson we covered in the class. Okay. Now, for concept, what I will do, I will go through the problems from the practice problems. At the same time, I will discuss one problem from your homework 2. So homework 1 was good. Almost all of you got 100% points. Some of you got extra points because of your class examples. That was good. For homework 2, most of you got full points for the problems I gave from the book. But for the lab experiment, some of you got some weird numbers. 0.2, 0.9, something like that. That is not the correct answer. So I assume you did the wrong unit conversion, and maybe you did the wrong calculation as well. So let's go through that problem, and that will cover the density, specific gravity, specific weight, the main part of this test. Okay? So for homework 2, lab experiment, give me the value you got. What was the mass of the water for your section? 3.815 kilogram. Okay. The area of the water was fixed. It was 1 feet square, right? What was the depth of the water you measured inside the tank? 3 point something? 4.15? 4.75? Okay, 4.15. Okay. Okay. So, and the temperature of the water was what? 23 or something. It was very accurate. Okay. I don't know why I get these lines. Okay. It's 22 point something, right? Okay. Okay. So those were the readings we got from the experiment. Now, the question was you need to calculate rho, you need to calculate specific weight and specific gravity in SI and FPS system. So that was the question for this experiment. Now we know we need to convert everything into the same unit. Either everything should be on standard SI or everything should be on FPS, right? So I will do the example on SI system, and you know how to convert into FPS. So SI system, do I need to convert the mass, or it is okay? It's okay because it's already on kg. I don't need to convert that. Area of the water, it's 1 feet square. I need to convert that, right? Now the conversion between meter and 1 feet is this one. So what I will do, 3.28 square meter square. Depth of the water is 4.15 centimeter. So I need to convert that into meter. So that will be 4.15 10 to the power negative 2 meter. And for the temperature at this point, for all of these three equations, I don't need to use any temperature. So I will keep the temperature as it is. But for any reason I need to convert that, I will do that. Okay? Now for the density, it was mass over volume, right? Now mass over volume, you already know the mass, 3.185. How can we calculate the volume? Area times depth, right? So area times depth is 4.15 10 to the power 2. Now give me the final answer with proper unit. Yes. Say it again. That's okay. Yeah, we need to convert that because it's in feet square. So when we convert that into meters, so we need to square that. Yeah. So what will be the density of water? It should be close to 1,000 or something. 988. Okay, I will just keep that. Kg per meter cube. Perfect. That was very close to 1,000, and that simply indicates that the measurement is good. Okay. Now, the gamma, either you can start from the very beginning by calculating weight and divide by volume, or you can just multiply the density with gravity. Okay. So it's 988, 9.81 Newton over meter cube. Give me that number. $9,690. Okay. That is pretty close to the actual answer also. Okay. Now the last thing, specific gravity. Now the specific gravity is actually like rho of any substance over rho of water, or gamma of any substance over gamma of water. This time the substance is water itself, right? So you should get one, or some of you, what you did, you used the experimental value over the standard value you got from the list or appendix. That is absolutely fine also. So maybe you got 0.99 or maybe you got 1.03. That is absolutely fine as long as it's close to 1. So this one was in SI system, right? Now the other part, SPS system, what you need to do, you can convert that into slug, right? You can keep as it is the area, you need to convert that into feet, right? And you will get, like you will do the same procedures. So for density, you will get maybe 1.94 or something, slug over feet cube. For this one, you will get 62.4 pound over feet cube. And for this one, you will get close to 1. Okay? And almost 60 to 70% of you got the correct answer. That is impressive. I'm very happy with that part. Some of you, most probably you couldn't convert the unit properly, and that's why you got some weird numbers. So for test, make sure you do the correct steps and the conversion rest of the part will be. Okay? Are we good with this question? The specific gravity here. So the actual equation for the specific gravity is density of any liquid over density of water, or the specific weight of any liquid over specific weight of water. This time the liquid is water. So like water by water, it should be 1 or close to 1. Okay, are we good? Everyone from the back? Okay, now I will discuss the practice problems, mainly the steps, so that you can work on that. So I gave you 5 practice problems. What I will do, I will solve number 4 and number 5 first, and then I'll come back to number 1. Okay? So let's go to the very, okay, this is number 4. Once we solve or once we discuss all the steps, you will see that you know the basics. It's just you need to identify the correct steps, or like how you know all the basics here. You will see that. Now for this question, they are asking you to find kinematic viscosity. And they gave you the viscosity of oil, which is 0.11 Newton second per meter square. Now I will start from the Newton's law of viscosity. That is the viscosity or absolute viscosity. Okay? And this is called mu. So mu is given. And you need to find the kinematic viscosity, which is something similar to V, which is called mu. And if you go to your class lecture about the viscosity, the relation between mu and mu is, what is that? What is the name of this symbol? Rho, and it represents what? Density, yes. Okay. So, the viscosity is already given, which is 0.100 Newton. How can I find the density? Density is not given in this question. Is there any way I can find density? Yes, so what is the way? How can I find the density? Exactly. Specific gravity is given. So, just a few minutes ago, we saw that specific gravity is rho over any substance and rho of water. This time we are using rho of oil. So, it will be specific gravity. Now, if density of water is not given during the test or this question, you can always use 1000 kg per meter cube. But if it's given, you just need to use that number. So I'm not seeing any specific density given in this question, so I will use 1000 kg per meter cube. So basically that will be 920 kg per meter cube, and I didn't cross that, I promise. That should be 920 kg per meter cube, and you can use this one. Okay, so that will be the answer for the mu or kinematic viscosity, and the unit will be, sorry, the unit should be meter square per second. Okay. So you see, you know all the basics here. You just need to figure out how to approach the problem, right? Okay. Are you good with this one? Everyone? So you should be able to solve this type of question, right? In class, if I just ask you reverse one, okay, density is that, kinematic viscosity is that, give me the specific gravity. You should be able to find that. Okay, so the very last one, this is a question from your homework 2, but I asked one extra question here. I asked what will be the gap between the shaft and the bearing. Okay, so in your rack class, do you remember you drew the side view, top view, left view, right view, something like that. So we will use that lesson a little bit. Here, I will try to see this whole picture from this side. Right now we have side view or the longitudinal view. So basically what is happening here, this is the bearing, like circular bearing, and this is the shaft. So that is actually coming this way, right? And the question is asking what will be the gap between this shaft and that bearing, okay? So if you look at from AA, section AA, the view should be something like that. Do you think that is the correct section AA view? If you look at from this side, everyone? Okay. Now, they gave you the diameter for the shaft, which is 32 millimeter. They also gave you the diameter for the bearing, which is 30 millimeter. Now they are asking what will be the thin gap between these two. So what do you think? What will be the thin gap between the shaft and the bearing? This side or this side or this side. You can measure from any side. It's circular, so it will be the same on any side. 2 millimeters or 1 millimeter? Anyone else? It should be 1 because we are asking about this distance. So in total it's 2, but on one side it will be actually 1 millimeter. And if I ask you this question in the test, at least 30 to 40% of you will say it's 2 millimeters. It's not 2 millimeters, it's actually 1. You can see from this picture, right? So the thin gap will be either the radius of bearing minus radius of shaft, which is 16 millimeter minus 15, 1 millimeter, or you can say 32 minus 30 millimeter divided by 2, again, which is 1 millimeter. Okay? So that was one tricky question from this type of question. I just wanted to discuss that, know how to find that. Okay? Now, the last part, that was a part of your homework 2. How can you find the surface area? This part, right? So if you draw these 9, so area of this is the surface area. So what will be the surface area? That is 50 millimeter. And the radius, this one is 30 millimeter, right? So the area will be 2 pi r h. And h will be what? 50, right? And the r will be? What will be the radius? 15, 1, 5, yes. And you solved that for your homework, so which is good. And I will stop here for this question unless you have any questions. So if I ask you something like that, can you find the thin gap between these two? Now the question is why I'm concerned about the thin gap. What is the use of this? The use of this function is, for any reason, if I ask you to calculate the shear stress, this dy is actually that thin gap. Okay, so that's why we need to know how to. For your homework, the thin gap was given, but if it was not given, that's how we need to calculate. Are you good? Okay. So if you are done with this one, I would like to go back to question number 1, and I will try to solve question number 1, 2, 3. We have 20 minutes. I should be able to discuss the steps. Okay, let's start here. In your copy, I think you will have some difficulties to read the question because I printed 4 slides on 1 page, but everything is on Canvas if you want to have a look on that. Okay, for question number 1, they're saying determine the weight of carbon tetrachloride that should be mixed with 15 pounds of glycerin so that the combined mixture has a density of 2.85 slug per feet cube. Okay, so what we will do, since it's a mixture of 2 different types of fluids, I will write down this way. Mixture, it will be mass of the mixture over volume of the mixture. Okay, and mass of the mixture will be obviously mass of the 2 liquids, right? So mass of the glycerin, mass of the carbon tetrachloride. The volume will be again the summation of total volume in individual volume. So volume of glycerin, volume of carbon tetrachloride. And do we know the density of mixture? 2.85. Okay, good. Now they are asking you to find weight of the carbon tetrachloride. That's what they are asking you to find. Now here, once I know that is the concept I need to use, I will try to find individual values here. What else we know in this question? Density of individual liquid, right? So density of glycerin equals to this one. Density is 2.44. Do we know the mass of the glycerin? Or anything? 15 pounds. So that is not mass, that is actually the weight. So what we can do, we can divide weight by 32.2. That will give us the mass. So that's how you can, now you know the mass of the glycerin, you know the volume of the glycerin, right? Let's work with mass of CP. .09. Now this time, do I know anything about mass or volume of the carbon tetrachloride? Both are unknown, right? Here. So what you can do, you can express the volume of tetrachloride in terms of mass. Okay. Now, what you will do, you will just add this one here. Now, how many unknowns you will have right now once you do everything on that equation? How many unknowns you will have here? Just one unknown. Is the mass of tetrachloride, right? So from that equation, you can get mass of tetrachloride. But the question is asking weight of tetrachloride, carbon tetrachloride. How can you get that? Great. So you will multiply this value with G, and that will be the answer for this question. Now you see, this is a multi-step problem. And in your test, if I ask you this question, I will break down into at least 3 or 4 individual questions so that you at least know what will be the procedure, like from where you need to start. Okay? Are we good with this one? If I ask you this one or some portion of that or the reverse question, can you solve that? Or can you at least try? Okay, that should be enough. Okay. So we have 2 more questions to discuss. The next, everyone is done with this slide? Should I go to the next one? Okay. So the next one, they are asking, this is a tank, a closed tank. For one temperature and one pressure, there was a gas inside this tank. Now they increased the temperature, but the pressure is same. They are asking you to find what will be the new mass and what amount of mass you need to remove from this tank so that the tank will not burst or something. Now, this question has one flaw. They said that the mass will be increased or something. That is not true. Mass can be changed. Mass is fixed. The volume will be increased. So the question should be, what will be the new volume to accommodate the expanded volume? But I will just go through this question, but if I ask separately, you will know how to solve that because the steps will be same. Now, tell me how many different conditions in terms of temperature we are having here? 2. Okay, the first one is at 18 degrees centigrade. The next one is 42 degrees centigrade. Now this question involved gas, pressure, temperature. What will be the best equation to describe the situation? Which equation we should use here? Gas, temperature, pressure. Do we know any equation only for gas? Ideal gas law, yes. So that should be pressure at 18, rho at 18, R, T, 18. Okay, 18 means 18 degrees centigrade. So you will find density. The same thing you will do here. Pressure at 40 degree, rho 40 degree, R. Oh, the pressure will be same. So actually the pressure is pressure at 18 degree because they said that to maintain the same pressure. So from there you can get this one. Now the question is saying how much like what amount of mass you need to remove from the tank. We know the density, but is there any way I can find the mass also? What is the way to find the mass from density? Density equals to mass over volume. So you can find mass 18 degree. Similarly, you can find mass at 40 degree. And difference between these two will be the mass you need to remove. Okay. Mr. Kipling.
I'm sorry.
Do you need some coffee? You can go.
I forgot my coffee. That's what it was.
Yeah, make sure next time you don't forget that. Okay, so that that is the advantage of being a student. I had a last night also. I couldn't sleep because of my daughter. I've seen some of the teacher here. I can sleep. I need to be out anywhere. Okay, so that one last question we need to discuss before we end this review class. Make sure you watch this video, okay? And the worst thing is this video is being recorded. So everyone will know what we did in this class. Okay, so that's how you can calculate this one. The very last one, as I said, this question has flaw. They are saying the mass will be changed. It's not true. The volume will be changed. So instead of mass, we should find the volume here. Okay. Now, the very last one. This question is pretty much similar to the question you had in your class example 4. You have two layers of fluid and one force, which is pulling one plate. And here, they are asking you to find the viscosity. Okay. We have two layers of fluid here, the same fluid with different depth or thin depth. You need to find out what will be the viscosity. So what you will do from this layer, calculate tau A. Since it's same fluid, viscosity will be same. From this layer, calculate tau B. This one. Can you tell me what will be the dy for tau A? What will be the dy? Like what is the thin gap? Okay. For tau B, what will be the thin gap or dy? 6. And what will be the du, the velocity? It's 6 millimeter per second. Because if you draw the velocity profile here, it will be something like that. Oh, I drew the wrong one. It should be this one. 6 millimeter per second, and here the velocity is 0. Okay, so you know the velocity, you know the dy. The only thing you don't know here is the viscosity. Okay, you also don't know the tau here. Now, if you read the question, they gave you the mass of the paint also. Whenever you see mass, that means there is a weight there, right? So what you will do from your statics class, we need to find out what are the different forces acting here. From the tau, can you write down this way? Can I write down if A over A for tau? And for tau B, can I write down if B over A and everything? So On upward direction, it has P, 2 Newton. Opposite of this movement, you have FA, FB. What else you have here? You have the mass of the paint. So what is the last force acting on this whole system? You have mass. So which force? The weight. Yes. So this will be weight, mass times gravity. Now if I write down the equilibrium, P is going out upward direction, if A is going downward, if B. So you need to find the dense viscosity from these equations. Okay? Because for this, if A will give you something, viscosity, if B will give you some number, viscosity. Okay? So those were few questions. Confused?
Yeah, just the last one.
Here, since I don't know the viscosity here, so you know everything else. You know the area, you know the dy or something. So basically your FA will be some function, some number multiplied with the viscosity. Yes. Similarly for FB, some number with viscosity. Now you know the P, which is 2. You can calculate W because you know the mass. The only unknown will be actually the viscosity. And that's what actually they are asking you to find. Okay. Now, all the questions we discussed, every question had multiple steps, right? So for your test, I will not ask you a big question. Okay, start from the very beginning and complete everything. If I ask some question, it will be broken down into at least 2-3 parts, and that's how you will know like which part you need to do first and what will be the next part and everything. Okay. So I request all of you, please go through the practice problems. Even if you don't submit, that's okay. You don't need to submit. Just go through the steps. If you can identify the steps and then check with the solution, at least your steps were correct or not. Okay. So do that. And if you have any question, email me. If you have any last minute question, logging into Zoom, I will be happy to answer your question. And other than that, good luck for your test. Make sure you make a very good equation sheet where you don't miss any question. Okay? Okay. Yes. FA is the force because how it was to what? Force over area. So for tau A, it will be force per area, like for side A, and you need to find the area and everything. Okay? It was the shear stress, you remember, for the Newton's law of viscosity. So that is the tau. So you need to calculate the area also to find this one. Okay? Okay. Thank you very much, class. I will see you on Friday.